Hi, welcome to our lesson of special right triangles. The objective is, how do we use properties of special right triangles to solve problems? In the previous lesson, you learned about how to find sides in a right triangle using the Pythagorean theorem, which was a squared plus b squared equals c squared. Now with this triangle, the right triangle, there are two types of special right triangles, and we're going to learn them today. Okay, the first one is the 45-45-90 triangle. The 45-45-90 triangle must be an isosceles. We've learned about isosceles. Isosceles means that there's two congruent sides in the triangle. So with the 45-45-90 triangle, we have a ratio. It's always used for that type of triangle. So you would see that these two legs, which I will mark, they are congruent. So this side and this side are congruent because look at the base. We got 45 and 45. So remember about isosceles triangle, if the base angles are congruent, then the sides are congruent. And vice versa, if the sides are congruent, then the base angles are congruent. So with that, change this. So then that means this will be n, and this will also be n, because they're both congruent. And in the 45-45-90 triangle, the hypotenuse, the one that's opposite the 90-degree angle, will be n square root of 2, or n root 2, as if you hear that anywhere else. So it's n times square root of 2, or n root 2. So this is all for any 45-45-90 triangle. You will see these ratios, n root 2. And let's say that I let n equal 1. Let me change the color. So let's say I had n equal 1. I would just basically plug in n wherever there 1 wherever there's an n. So for this one, this side was n. Oops. Do that over again and press select. This would be 1. And since this is congruent, this is also 1. And then if let's look at this, n root 2, so it would be 1 root 2, or 1 times square root of 2, or just square root of 2, because the 1 there is implied. So there you go. So if there's any problems where you had to deal with finding one of the sides based on the 45-45-90 degree triangle, then you just plug in whatever n is and place it in whichever side that you're looking for. We're going to do examples of this so that way you get a better understanding of how to apply the ratio for the 45-45-90. So the steps are label with the side ratio. So that's n and n squared root of 2. Then solve for n. So let's say you didn't have the n and it was here, then you have to figure out what the n, you're looking for the n, then you have to figure out what that n is so you can plug it into the respective sides. Then you plug in to solve the original question. So when it comes to the 45-45-90, when you put those two triangles together, it will create a square. So the two congruent isosceles right triangle, when you have that hypotenuse cut through, it's a diagonal, and it creates the two congruent isosceles right triangles, as you can see, 1 and 2. Notice you got the green parts, that's the congruent sides. You make another one, the same thing, and then with the angles, 45-45 for one of the triangles, and then the other triangle will also have 45-45. When you put it together, you got all four congruent sides, and then you got those the angles congruent to each other. It would be 90, 90, 90, 90. You've got a square. So with the 45-45-90, when you put together, we'll create that square. And also, like I say, the diagonal will create two congruent isosceles right triangle. All right, so we're going to do examples based on the 45-45-90. So for this one, they say solve for x and y. They gave us, put They gave us this piece, this side, 7 root 2. This one's x, and the hypotenuse is y. And we know it's a 45, 45, 90. So I'm going to just state that this is 45, 45, 90. And that means the triangle that we're going to use, the ratios, the congruent sides, will be x. You can use n, any variable, which I should have mentioned. I use n, but if you had like x or b, whatever variable, as long as it's consistent throughout the problem. But I'm going to use n for this. Actually, yeah, n. And then this would be the hypotenuse is n root 2, or n times square root of 2. All right, so I have the side ratios, and I know that this is n, and this y, which we need to solve for, is n root 2. Okay, now how do we start? Let's look for something that's already given, and we could start off with that. We notice that this side is 7 root 2, which is also equal to n for that ratio, that side ratio. So I'm going to put n 7 root 2. And I'm going to use another color so that way I can start labeling and doing what I need to do. So then that means this side, since it's 45, 45, 90, this side has to be congruent to this side. So then that means x is going to be 7 root 2. So I'm going to put x equals 7 root 2. So I already found 1. Now I need to find y. All right, I see that y is also equal to, that side, the hypotenuse, is equal to n root 2. So wherever, I already solved for n, which was 7 root, which was already given, 7 root 2. So I just plug it in. So I'm going to put y equals n root 2, and then we know that n is going to be 7 root 2 times root 2. That root 2 is the one that's existing there. This is our n. And I'm going to highlight that so that way you know that's what I am substituting n with. And then I'm just multiplying the root 2, which was already there. So now I'm going to simplify. So again, you're multiplying radicals. You already learned this. I don't want to see any decimals with this. I need to see radicals or the most simplified form for your answer. So we know that when we multiply radicals, the same number underneath the radical. So it would be 7, and then let's say radical 4, because 2 times 2 is 4. And then you simplify further. 7 times, what's the square root of 4? It's 2. So then it comes out, so 7 times 2. And then you will get y to be 14. So I'm going to plug in my 14 as my answer. And there you go. X is 7 root 2, and then y is 14. And you solve it using the side ratio for the 45, 45, 90. Okay, let's do another one. Okay, so solve for A and B. So again, we're doing a 45, 45. I'm going to write that so that way we know we're dealing with that special triangle. And we know that the side ratio is n, and the hypotenuse is n root 2. Alright, so now I'm going to use that side ratio, and then I'm going to label it on the triangle that's given. So this is 45, this is 90, this is 90 degree marker. Then I know this is a 45. So since the base angles are congruent, then the sides are congruent. So that means whatever I find for A will be the same as B, and vice versa. For B, it'll be the same for A. They gave us the hypotenuse. Remember, the hypotenuse is always opposite the 90 degree angle. So they gave us the hypotenuse, and then when I look here, that means the n root 2 is equal to 9 root 2. So I'm going to put Actually, I put that in another color, so let me undo that. Put that in green because I labeled it in green. So this is my n, this is my n, and this is my n root 2. Now I will start figuring things out. So since this is my n root 2, that means my n root 2 has to equal what was given, so 9 root 2. But notice where the n is located. And I'm going to highlight that. So notice where my n is, right in front of this, the root 2. What's in front of the root 2? 9. So then 9 is, n is going to be equal to 9. So let me get blue. So then that means my n is equal to 9. So if that is true based on what is given for the hypotenuse, then my n, my sides, which is n, will also be 9. So this is 9 and this is 9. So then I found A, which equals B, which gives me 9. So then I have my sides for the 45, 45, 90, got 9, 9, 9 root 2. Again, all using the side ratios. This will take a while to figure out, but once you figure out the pattern and what's going on, then the rest should be easy to do. All right, let's do another one. This is a 45, 45, 90. And I'll just put that on top so that way we know what we're working with. 45, 45, 90. And then we know that the sides, this is 45, 45. That means the sides has to be congruent. It's an isosceles triangle. And we know this is n, this is n, and then this side is n root 2. All right, so they want us to solve for x. X is one of the legs. We don't know what it is, but we do have the hypotenuse, which is 6. So I'm going to set up an equation so that way I can solve for n. Since the hypotenuse is 6, and based on the ratio of the 45, 45, 90, this, the hypotenuse is n squared of 2, or n root 2. That means whatever I get for this has to equal 6. So that means n root 2 equals 6. Now I need to solve for n. When you're dealing with radicals, and you have to isolate the variable, for this one, you're going to divide. So for this one, there's the first option, you're going to divide this root 2 on both sides. So that will cancel this out, and then you have n by itself. Now, you can't leave the answer like this, because what you learn from algebra, you need to rationalize the denominator. Notice that we can't leave any fractions or anything with fractions or radical signs in the denominator. We need to rationalize it. We need to do something so that way we have a whole number at the bottom and then do whatever we have to do on the top. So when it comes to rationalizing, so I'm going to do the steps here, and I'm going to use another color. We're going to multiply what's at the bottom to both the top and the bottom. This is rationalizing the denominator. So once we do that, only taking what's underneath the square root, and then we're rationalizing it. So that means when you do the bottom, the top one will be 6 square root of 2. And then the square root of 2 times square root of 2 is square root of 4. And the square root of 4 is just 2. So it would be 6 square root of 2 over 2. But look at this. You can go further because 6 divided by 2 gives us 3. You can reduce this fraction. So then you'll end up with 3. And since you didn't do anything with the radical 2, nothing to cancel out, whatever, it'll stay as is. So then your n will be 3 radical 2. And that will be for x. So x equals 3 radical 2. Okay, so this, again, if you were able to set it up with no problem, no the side ratios, good. This is the part where most students just mess up and end up using decimals. Don't give me a decimal, because when it comes to any exams you have to do, they're going to ask you to rationalize. They don't want to see any square roots, and they're going to give you options. And if your answer is in the form of a decimal and it's not one of the choices, you're going to be stuck. So use this method in order to rationalize the denominator. And I will stress that a lot. Rationalize the denominator. Do not give me a decimal. All right, let's do one more with the 45, 45. All right, so it says a square has a diagonal of 6 units. So we need to draw the diagonal, and I'm going to draw that. And then I'm going to label. So they said that it is 6 units, so it's 6. Find the perimeter of the square. All right, remember what we said about the square? It's basically two isosceles triangles put together to form that square. So that means this side, this side, this side, this side, they're all congruent. So if that means the two sides are congruent, then we know that this is a 45 and 45, 90 triangle. So I'm just going to focus on the one of the triangles. So I'm going to highlight this yellow so that we focus on that one. And then I'm going to label it with the ratio, since it's 45, 45, 90. So this is n, and this is n root 2. All right, so now we need to find n. We know that the hypotenuse is 6, and it has to equal n root 2. So whatever we have to set it equal to each other. So this n root 2. Again, this looks like what we did for the other question, for number 3. So then we divide square root of 2 on both sides, and then we had to rationalize the denominator, so that way we have no radicals in the bottom. So this would be 6 square root of 2 over 2. Because 4, well, you multiply, gives you square root of 4, which gives you 2. And then you can simplify further, which is n square root of, 3 square root of 2. So that means our n, that side, is 3 square root of 2. And since all the sides are congruent, we need to find the perimeter. So the perimeter will equal 4 times 3 radical 2, because all the sides are 3 radical 2. And then 4 times 3, 12, and then you leave the radical, the 2 underneath the radical. And in units, of course, we need to put our units. So there's our perimeter. And so applying what you learned about 45, 45, 90, and then go in the next step to find the perimeter of the shape. Okay, so that is one of our special triangles. The next one we're going to learn is 30, 60, 90. 30, 60, 90 triangles are formed by an equilateral triangle and its altitude. And you know altitude means height. So here we have the triangle. So we got the isosceles triangle. Sorry, equilateral triangle. Equilateral means that all the angles are equal as well as its side. So notice that 30 gives you 60. So we're only taking the red highlighted triangle. So the side ratios for the 30, 60, 90 is, okay, going based on the smallest angle, the opposite will be the shortest leg, which would be n. Then the next angle, the next shortest angle, which is 60, the opposite will be n root 3. And then the longest side, which is opposite the bigger angle, which is 90, will be 2n. So basically the shorter leg will be half the hypotenuse, and in reverse, the hypotenuse is twice the shorter leg. All right, so the steps, the same as if you did the 45, 45, 90. You label the side ratios, you solve for n, and then you plug whatever you solve for n into the original question, or the side that you are trying to look for. Yeah, or maybe another side that you need to find. So the summary rule for the 30, 60, 90 triangle is that the hypotenuse is opposite the 90-degree angle. It's the longer side and it's the opposite. I didn't put longer, but yes, it's the longer side and it's opposite the 90-degree angle. And the long leg is opposite the 60-degree angle. So that would be the second shortest angle, which would be opposite to that side. Okay, so we're going to do examples with the 30, 60, 90. So for this one, it says solve for x and y. So we know this is, you see 30, we know this is 90, so we know that the other one has to be 60. Because all of these angles have to add up to 190. I mean, sorry, 180, my bad. And if you weren't sure, you could add the 30 and the 90, subtract by 180 to give you the 60. So since we know we're dealing with the 30, 60, 90, I'm going to label the sides with the side ratio. So let's remember, for the short leg, it's going to be n. I'll put n here. And then for the long leg, that's going to be n root 3. And then for the hypotenuse, it's twice the short leg, so that'll be 2n. Alright, so now let us solve for x and y. The first thing we need to look for is anything that we can work with as given. They gave us a hypotenuse, which is 20. So that means whatever we find for 2n has to equal 20. So then we can set up the first equation. So 2n equals 20. We know we divide 2, it gives us 10. So that means wherever there's an n, we need to plug in our 10. So for y, which is n, is 10. So we found that. And then for our x is n root 3. So we found n to be 10. So then it would be 10 root 3. And then there we go. We found the two sides using the 30, 60, 90 side ratio triangle. Okay, let's do another one. We need to solve for PR or RP or and QR. So that means the two sides. So I'm going to highlight that so we know what we are looking for. We're looking for this, and then we're looking for RP. I will use blue for that one. All right, so now we know that this is a 30, 60, 90. At the 30, we know this is 90, so this is going to be 60. So we use in the 30, 60, 90. And the one side that they gave us was the short leg, because it's opposite the smaller angle. We'll have 4 root 3 over 3. All right, so we need to find the blue side and the green side. So I'm going to label what, use another color for that. Actually, no, I'll just use the purple. So I'm going to label the sides with the ratio. So I know that the hypotenuse is twice the short side, so it's going to be 2n. And then this side is the short side opposite the smaller angle will be n. And then the second smaller side, which is opposite 60, the blue side, the ratio for that is n root 3. All right, so I labeled it. Now I can start trying to figure out the sides. First I need to find n, and then I can work my way from there. And see, so I'm going to work with what I have. I know that n is equal to 4 root 3 over 3. So that one was in purple. Since it's highlighted, yeah, purple, I'll put it there. So I know that n is equal to 4 root 3 over 3. Now it's a matter of me plugging in the information that I have into the other parts. So I'm going to use the blue side, RP, which is equal to n root 3. And since we found n, we just plug in 4 root 3 over 3 times what's already there next to the n, root 3. All right, so again, we gotta simplify. Since there's that invisible 1 in front of the root 3, Whatever's outside the radical, you multiply together. Whatever's underneath the radical, you multiply them together. So then that means this will be 4 times square root of 9 over 3. And 4 times the square root of 9 is 3 over 3. And since you got 3 on the top and bottom, you can cancel them out because they'll give you 1. And then you have 4. So then that means our P is equal to 4. Okay, so we found the blue side. Now let's go on to the green side. So that green side is QR, and it is labeled as 2n. We already found out what n was when we did this side ratio. So then 2 times 4 root 3 over 3. That doesn't look like a 3. Let me change that. Okay. Let's multiply. All right, so now we just multiply straight across. So we got 2 times 4 is 8. And then you just leave the radical as is, and it's over 3. Nothing to reduce here. So then that's it. QR is equal to 8 root 3 over 3. And our P is equal to 4. And we found our sides by using the side ratio for the 30, 60, 90 triangle. Right, let's do one more. Again, we're solving for x and y. So what I'm going to do again, I'm just going to highlight. So that way we can distinguish the sides from each other. All right, and now let me label with the side ratio. I know this is going to be a 60, 30, 60, 90. I got a 60 here. This is a 90, so I know that this is going to be a 30. So that's done. Because this is a 30, 60, 90, then we need to label the sides with the ratios. Let's start with, well, we already have this side, and we're looking for x and y. So the shorter side, which one's the shorter side? It has to be opposite the smaller angle. This is 30, so this would be the shorter side. So this would be n. And we know the hypotenuse, which is opposite the 90-degree angle, the green side, is going to be twice the shorter leg. So that means 2n. And then we know that the second shorter side, which is opposite 60, is going to be 3n root 3. All right. Once we got that label, we can start working to find n and plug in everything in for n to find our other two sides. So we know that this side has to equal 9 root 3 over 2. So that means, that n root 3 is equal to 9 root 3 over 2. All right. We already know what n is based on how this is set up. So I will show you. Hopefully the highlighter doesn't fully cover it. All right, so you see where this n is? And we have that root 3. Let's look at this. This is root 3. Look what's in front of it. The 9 over 2. So that is what our n is equal to. So anytime you see that root 3 underneath, and you have to look at the number in front of that radical sign. That will tell you what n is. So that n is equal to 9 over 2. Now we can start plugging in and finding our other sides. So for the blue side, it's y. We have n, which is equal to y based on our side ratio. We found n, it's 9 over 2. And then for x, which is our green side, I need to box that first, so that way we information, good. And then our x is 2n. Our x is 2n. and we have found n to be 9 over 2. So 2 times 9 over 2. And you know that the 2's will cancel out because there's one on top, one on the bottom. So that'll leave us with 9. So our x is equal to 9. So then we have our sides. We have 9 root 3 over 2. Our x is 9, and our y is 9 over 2. And there you go. That's using our side ratios for these two special triangles in order to solve missing pieces, missing sides of the triangle. So just to recap, we are at the end. So we learned about the two special triangles. We learned about the 45, 45, 90-degree angle of triangle. Basically, it's an isosceles triangle. The two sides, the two legs are congruent because the bases are also congruent, and then the hypotenuse opposite the 90-degree angle will give you the root 2. So you have the ratios for the 45, 45, 90 is n for the legs, and the hypotenuse n root 2. And for the 30, 60, 90 is formed from an equilateral triangle with the n the altitude. So taking that piece, that little piece triangle from the equilateral triangle, you will get the side ratios of n, 2n, n root 3. N represents the short leg, opposite of 30. N root 3 represents the second short leg, opposite of 60. And 2n is twice the short leg, and it's opposite the 90-degree angle. So it's the longer leg. And when it comes to solving these problems, you have to tell yourself, is it 45, 45, 90, 30, 60, 90? Once you know that, you label the sides, and then you use the information that's given, and then solve for your variable, and then plug in and find the rest of the sides. Okay. This will take you a while to figure it out. It takes practice. If you have any questions, feel free to email me, and I can give you more examples, more steps to help you out. And with that being said, this concludes our lesson. Have a good day.